Do you even test, bro? Bruh. Testing is an absolute fundamental practice for any piece of software that cares about quality, consistency, and longevity. Testing is what gives your code an actual measurable quantity that expresses how much trustworthy your software is. It is so important that even some books wrote on how to best write those. Even how you should actually develop your whole software in a way that you do tests first. So first you write all your test cases, what your expected things your software should do before you even deliver the feature itself, which is called test-driven design or test-driven development. Sometimes it works. Testing is so important that we very easily find frameworks or libraries that we can use to write tests very easily and also scale those up if necessary. In today's video, you will learn how to write your tests for C++, of course, using the most used framework there is for the language, which is GMock and GTest. Hi, my name is Marcos and this is Practical Software. The concept of testing is really straightforward. It basically tries to answer the question, is this working? Is your component working? Is your class working? Is your function working? So testing is a way to objectively answer the question, is this thing working? It doesn't matter how beautiful you have written your function. It doesn't matter how fast you have delivered this feature. It really doesn't matter. What matters is this working? And the testing will objectively give you that answer, at least if you write the tests well, naturally. There are many types of software testing out there in the industry. It really depends on what kind of application we are developing. Is it a web application? Is it a desktop application? Is it a mobile app? So depending on what kind of application, different kinds of tests may occur in the development lifecycle. There are a whole bunch of different tests we can do in any application. If we care about performance, there are performance tests. If we care about throughput, to see how large we can serve the network, let's say, there are throughput tests. If security is an issue, there are security tests. If we are developing some kind of UI or application, there are usability tests to see if things are in place or intuitive. So every possibility you can imagine, there probably is a type of test that tries to cover that. However, regardless of what kind of software we deliver, there are three fundamental types of tests that should be part of any application. Those are unit testing, integration testing, and system testing. Let's quickly go through those three kinds of tests, while considering a particular application that I have worked on before, which was a portable laser 3D mapping system. Unit testing is the most fundamental, elementary kind of testing that we know of. It concerns the very foundations of the software. So if we think about software classes, for example, we have a C++ class or a Python class. Usually those are the fundamental components that belongs to our software as a whole. The smallest building block of your software. And unit testing cares about how is this building block behaving? Is the methods of this function well delivering what they are supposed to deliver? Is if I gave a specific set of inputs to that function, is it gonna give me the expected output? So those are the kind of questions that we should ask when writing unit tests. When talking about unit tests, it is very important that we introduce the concept of mocks. Mocks are, by all means, objects that replaces or mimics the behavior of other objects or resources. For example, imagine I am to write a sensor driver that processes data from a LiDAR or a laser sensor. This laser sensor, it is a physical system, it's an actual physical sensor that I connect to my computer using the network. However, you can imagine this can be expensive. I need a sensor, I need to plug it in my computer. How do I test this in a pipeline? How do I scale this? How do I check for every possibility, let's say scenarios, having always to connect my sensor to my computer for this to work. So this is a really good opportunity for me to completely mock this guy, aka replace it, aka mimic its existence or presence, so I can properly test the thing I am concerned about. This is possible using mocks. So the mock, instead of my system, let's say, depending on my laser sensor, it's gonna depend on something else, my mock sensor. And then I can really test the component as if the sensor were present or connected. So this is a very simple example on what kind of scenario we can think about when writing unit tests for the sensor driver without having to care about needing to connect a physical sensor for the test to work. And once the mock is in place, I can call methods that would invoke this dependency and then use the mock to return me the actual things as if the real sensor was there. So imagine if I didn't have the mock, I do a call named get data, and then the get data would go to the network, and then the network reaches the physical sensor, then the physical sensor talks to the embedding computer, give me data, and then the whole thing goes back, and then I have my data. So the mock would do this whole thing for me. Actually, it would replace the whole thing for me. This behavior of fetching data from the physical sensor would be done by the mock. The mock would return the same type, the same data with, let's say, dummy values, just so that I can use the same function as if the sensor was there. So I shouldn't care that the sensor is there anymore. I can care about what do I do once I have this call. What is my driver supposed to do now? The get data is essentially mocked, and now I can really care about what I do next. What is my driver supposed to do once I get the data? And then we can start to think about the scenarios, and doesn't care about the existence of the sensor. What if this happens? What if that happens? And therein comes the power of the mocks. Okay, enough about unit testing. Let's talk about integration testing. So right now we have, everything about unit testing. So you know how to test these individual pieces of software, these elementary units, these building blocks for your software. But at some point you want to actually test the real thing. You do more, let's say, close to reality tests. So integration tests, they care about how the relationship between the different units of your test are now behaving. Is my driver working well with the physical sensor? Is my driver working well, for example here, with the laser data processor? So what happens now? The question is, what happens if I put all those guys together and press the run button? So this is the integration test. It's more rigorous. It uses much less mocks, or fewer mocks, I should say. It uses fewer mocks, so the system is more like it's like more real, let's say. So for this example, maybe it is now a good idea to turn on your sensor, plug it in your computer, and run the integration tests, because now we are more serious about it, let's say. Not that unit tests are not serious, but I guess you get a point. Finally, system testing. Now bring the big guns, because system testing involves your whole system. Now the concern is the whole package working? And the system testing can be really expensive depending on what your software do. So again, for the case of my laser 3D mapper, the question is it working as a whole thing? I don't care about the small part anymore. I don't care much about the relationships anymore. Of course I care, but the question is everything working? Now, for this example, I would pick my hardware, I would pick my laser sensor, I would pick the drivers, I would connect to the network, I would press play, I would turn everything on, I would do the scanning, I would see the data that it's producing, I would probably compare with some kind of database with the ground truth, and then I would see, yes, I want to objectively say my whole system is working. Again, I guess you get the point also that the tests becomes more expensive the more you get away from the unit testing, because you're involving more components and more resources, but this is the part of it. It's part of testing, it's part of caring about your software, how far you want to test, how far you want to go, how much of resources you want to use, how invested are you in this, on the concern of how things are working, if everything is working. Put everything in a balance and try to answer the question, is it good enough? And then it's up to you. I think it's time we get practical. Today, you learn exactly how to use GMock, GTest, of course, with Cmake, and how to write your tests, how to use the mocks, and a very particularly important concept called dependency injection. Let's get to it. So what we have here is it's a project. It's already a prepared project, so I did this beforehand. And let me walk you through it. So here we have a Cmake list. So this is how we manage our project. And for this particular purpose of explaining about testing, we're gonna go testing a library. So this library is our target test. This is the thing we want to test and apply all those testing concepts. I call it an algebra class. It's just a class, it's an object, and this is how we build it. And we have a consumer app. This is not needed. This is just for us to, in practice, invoke the library in a way. It's not the point of today's video. Let's have a look at the library. Well, this is a very simple class. Again, the thing we're going to test. And it has a few functions. It has supposedly long operations. And here is where we see a hint of what the dependency injection is in practice. All right. And if you go to the app, it's just a very simple way just to invoke this library, because those are two separate things. So my application is a consumer thing. It's a client. And my library is something else. And my library is the thing I want to test. So this is just for us to be sure that this whole thing is working. So this is the Cmake again. We're gonna go to build. So there's a build folder. I'm gonna do cmake ... So it's configuring my project, and then I do make. All right, so looking good. If you're in Windows, you can do cmake -- build . It also works for Windows. And yeah, so I just built the library. I built an app. I can just invoke the app like this. Of course, it's a simple app. All it does is use one of the functions that we will possibly be testing from the library. So what I did, I just invoked this guy. Now let's talk about dependency injection in a nutshell. So dependency injection. Dependency injection means that you're exactly as the name suggests. It means that your dependency, so let's say external components of your software, are injected into the components that needs them, but this is made by means of an interface, right? So it's very important, this concept of interface, because our main class, which is this guy right here, in this diagram, it shows that it depends on an object called noise and an object called logger. But dependency injection is, instead of depending on those, let's say, concrete implementations of those objects, it would instead depend on their interfaces. So imagine this guy, it's inheritance from another object called iNoise, and this I stands for interface. Usually it's just a standard convention. And this other one inherits, oh look, this is a nice arrow. It inherits from another interface called iLogger. And now this is the beautiful part of the dependency injection. My algebra class depends on the interfaces. In practice, in C++, how does this look like? Just like this. If we go back to the library class, we can see here the dependencies, they are exactly those interfaces that I explicitly highlight here. So indeed, there is an object. Actually, there is no concrete object, noise object. There is just an interface definition for this object. I don't have to do implementation of this object, which is already, and maybe you already see some benefits, but this is very important. So all I have to do is that make sure my class depends on interfaces and not concrete implementation. I'm gonna show you why in a moment. And dependency injection means that my class, my algebra class, it depends on the interfaces. I may be repeating myself, but this is important that you grasp into this concept. We depend on interfaces. And now you understand why this is so important. The reason is, when you are testing something, it can be that we don't have any information about some concrete implementation of some object. All we care is the interface. Imagine this guy, it's an expensive object, it's an expensive resource, and it would, do network calls and use drivers and interact with the physical thing. Again, I don't want to do this. I'm curious about testing how the algebra class is using the interface and not using the object. So the interface is really important. By means of an interface, I can use, let's say, a pointer to that implementation as if the thing was there and have it effectively mocked. So it's not the real thing. It's something that really looks like the real thing, but because it inherits from the interface. So what I can do is I can have a mock object here, and I can have a mock object here, a logger, and this one will mock a noise. So I don't need to have those guys anymore. I just need the interface definition, and my algebra class will behave exactly as if the real thing was there. And this is the concept of mocking, using and benefiting the concept of dependency injection. All right, so back to the code. How do I write the test? How do I use this mocking thing? How do I do stuff? I'll show you. So the first things, as we are always practical, I'm gonna show you how to bring in, so pull in Google Test and Google Mock as a dependency to your project. So we need this framework to write our tests over. And the way we do it is by, I'm gonna just copy paste for efficiency purposes. This is how we do it in the Cmake way. So walking through it. Usually you want to have your testing built as an optional thing to your project. You don't want to require them to build a test. This should be an option to them. And usually it's turned off. But like you're in the development environment, usually you want to turn this option on, and this is how you do it in Cmake. You just define an option, you define some description of it, and the default value. If the set option is turned on, then everything else is read and parsed and processed by Cmake. So this is a Cmake syntax. It tells your projects enable testing in a general manner, meaning that Cmake will be aware that testing is done, and this allows you to call something called ctest, which is kind of a high level command line that Cmake offers the users to look for the testing and execute them right away. Of course, we need Google Test. So if you don't have it, you should install your local machine. And if if it's a special drive that you installed it to locally, you can just use this syntax to point it directly to the path. You then include, so when you pull Google Test, you include a list of useful commands. This is just a printout in Cmake language. We want to add executables, so our actual tests are executable in the end of the day, and this is how we define them. And of course, we want to link our testing executables to the framework that we are building upon, and this is how we do it. So for starters, I'm gonna do like this, and of course finally we have Google Test discovered the test. So Google also helps us kind of filter through the tests. If you have, let's say, hundreds of tests, Google Test allows you to filter them and process in a way that is very convenient for scale purposes. So yeah, I should do cmake ... If I don't explicitly tell build tests as an option on, then it's not going to discover it. It's not going to build the test. So I have to do this, cmake ... the build tests equals on. Now I am actually processing this part of Cmake. And of course we have to create a test source file. It's an executable, so we have to have an entry point. And because Google Tests use those two arguments, it's good that we already defined them, and we should be good to test. Perfect. And now we're gonna pull the actual testing library. So GTest, GTest.h, include GMock, GMock.h. And we are good. It builds, and for the usual Google way of initializing this is just like this. So there is a namespace, init, I think, yeah, Google Test, and then we give it to argc as a reference, and then argv, and we return run all tests. All right, what I'm gonna do is do like this. So not the app, sorry, I did tests. Yes, and you can see here that the kind of a framework is already being used. So it's looking for a test and trying to run them and see if our expectations are met. This is how we define a test. So you literally type test. You give it kind of a test suite name. It's almost like a test class or a test fixture. It's something that's a way to categorize a kind of test. Let's call it just testing. And the actual test name. So I'm gonna test algebra. Actually, I'm gonna test a function. So I'm gonna test square2, which is a method. Actually, this should be called algebra class. It's much more, it makes more sense. And of course, our testing executable, it should pull our library as a dependency, because this is the thing we're testing, so it's important. All right, now let's try using the class. Let's say, oh, of course, if I make and execute the tests, we have our first test and it's passing. Yay, we have a passing test. You should be proud. Okay, let's actually test the function. So this function, it's supposed to square things to the power of 2. It's really straightforward. So I'm gonna create an object. And I'm gonna call the function that I want to test. So alg.square2. So and therein comes your testing mentality. So this is where we, or most of the times, are creative, and then we think about different scenarios, we think about different set of inputs. We should know about the outputs, so we should be very aware of what are we actually expecting for those tests, and then we explicitly write our expectations. So everyone knows that the power of 2 of 5 is 25. So what I'm gonna do is I'm gonna do this, and this is how we explicitly tell Google Test to check for the value. So expect should be near 25. I use expect near because it's a float, so it can vary a bit, depends on the machine. But I'm gonna be somewhat rigorous. So this is your very first test. Let's see if it passes. It passes. Let's do a sanity check. So this should be a failure, and it is a failure. Let me make this bigger. And it tells you more or less, some kind of report. Amazing. So this is your very first test, and it's passing again. Congratulations once more. Of course, you can combine different expects. You can just do something like, you can directly inject the function here. So 25 times 25 is 625. I knew it. Let's see if this square2 still works. It does. So that's cool. So here, the important part here is that you are, as a programmer, as a testing engineer, you are, expressing your expectations on your function, right? And there are cases, depending on the project you work on the type of industry that you work on, there are cases that the testing engineer doesn't know anything about the class that it's being tested. All he knows is a vague interface definition and the method name and some inputs. And sometimes this is a good thing. So sometimes whoever tests your thing should be a different person that doesn't know much about it. So it can get more creative. And this is a very important concept, that whenever we test, we should be checking behavior, expectations, and not implementation details. I shouldn't care how the things are working. I should be caring about the results. So testing is, it's quite a mentality that we have to be aware of, which is enjoyable for the most part. All right, let's explore a little bit more in the library. So this is how we expand our tests. So instead of testing the square2, I will test square2 noise, and I'm actually gonna test a particular behavior here. So here, if the noise is not found, which is me not explicitly defining this noise guy, this object, so my function should throw an exception, and Google Test allows us to verify this behavior. So again, I'm gonna use alg. I'm gonna call a square2 noise, but I'm not gonna give it any object. It doesn't matter because it's not gonna work. And if I run this, of course, something weird is gonna happen. So an exception was thrown, but I didn't catch it. I didn't explicitly tell Google to against this. So there are a few ways to do this. We can do either like this, expect throw, and we can put the actual function inside this. So this is an expression that is we can put in the first argument, and then I can write what is the type of the exception I'm waiting for. So this was a runtime exception, and this is inheriting exception from the main std library, and now this should work. And of course, if I didn't do this, if I didn't have an exception, this is a failure because exception should be thrown, which is the default behavior. Right, now let's talk about the mocks. So go back to the class and see to these interfaces. So if I look into in the interface, I will see a virtual function, meaning that whoever inherits this has the option. Actually, it's not defined, so it's mandatory that it's going to define this method. And we can see in the algebra class that we invoke whatever implementation from this interface a method. And this is where the mock comes. So I've already prepared a very simple mock class using the Google Mock framework. So Google Mock allows you to create a class that will mock your real thing, your object. It should inherit from that set interface definition. And it's pretty much like any class, with the very nice addition that Google Mock has defined those boilerplate code methods with verifiable calling behaviors. So this is how we do it. We invoke this macro. We define whatever it's gonna return. We define the function name. We define the inputs, and we can tell if it's a const method and if I am gonna override it. This is enough. This is enough for you to create the mock in Google Mock. And usually these mocks, they are located in the testing, let's say testing part of your project. So it doesn't belong to the production. It's much more related to testing. It's debatable. But what is important is that we have to define this somewhere, either inside our testing or in some other place. Okay, nice. We should be able to use it. So what I'm gonna do is I'm gonna create a new test case, and I will create a new algebra class, but I'm gonna pass the mocked class inside this. And this is how we do it. So first, of course, we define a mock. I will add our very nice mock, and I will create an object of this mock. So it's called mock noise, and I'm gonna create a class, and I'm gonna inject the mock into my class, and the mock will help me figure out if the class is using the interface well. And this is how we do it. So instead of passing a real object, I pass the mock object. I'm gonna compile just to be sure. Yes, I have duplicated this. Square to noise throw, right? All right, of course it passed. And now comes our expectations description. What am I expecting? So Google Mock, this is how we use Google Mock for expect call, and we have to do this before we actually call a method. So what I do is I expect the noise object, the mock noise. Let me give it a better name. So it should call something. What it should call? It should call the add noise, and then I call the actual method from the system under test. So this is square to noise. So this function is just a bit of a detail. So what this function does is it squares the number 2 and adds some noise. So I am expecting my my mock to be called, the method from my mock to be called, and this is how I tell the Google how to do it. This should be enough. So if we are just interested in if my system under test is calling well using the mocks, this is enough. Sometimes we are interested in the results also. So we can of course extend our expectations in the results. And this is important because we can have some tuning in the mock. We can make the mock a little bit smarter and return specific values. I'll show you in a bit. So let's say we will have some results. Yeah, if everything goes well, or let's say this guy just returns 0, we will just square 2 normally. And then I can do expect near, pretty much this one, and it should work. It's still passing, nice. Let's now add some kind of intelligence to the mock. So let's force our mock to return a specific value. So we really check, because so far we are checking if this is working and this is being called. But let's say I want to check if this is really being added, right? So my testing went a bit further into the behavior, and this is not really doing it. So what I can do is, if I look at this function, I see, I'm adding something, so I know the result of this. I can tell my mock to give a specific value. I will add them up in my expectation, and then I will have the result I was waiting for. So let's do this. And this is now nice because we can do very simply in Google Mock. So this whole expectation thing will once, and then usually we use the namespace. Return, let's say 1.0. And this is programming the mock that it returns 1 when it's called. And you can tweak it into return repeatedly, return once. We want to go be conservative here. So if I'm sure I'm going to call the method just once, I will use will once. Now my expectation should not be 25, it should be 25 plus 1, right? Yeah, then this is how we do it. Now the actual mock is being called. It's going to return a specified programmed value, and I can check if this is really being added. I hope you are getting into the mock thing. I hope you are onboarding with this idea of really testing your classes. From this point forward, it's much more about getting used to the testing framework and getting used to this mindset of testing and of being creative about your scenarios, being careful not to test too much of a thing, so try to cover this. There are many tools out there that helps us do this. There are lately technologies that even generates these test cases for us. Maybe it's good to think about the importance of testing and how easy it is to set up your own testing infrastructure. Have your testing mindset, follow your project, your product as a whole. All right, just for completeness, we can also, do the same for the logger class. So we had so this is one way to inject our dependency. So we can inject dependencies on the construction of our object, of our system. We can also inject dependencies as a setter, and then we this injected dependencies properly used whenever called. So yeah, for example, here you can just add a new test case. Before that, this is how the logger would look like. So if we can see the logger interface, it has a bunch of virtual functions we inherit then. Because our mocking object is going to inherit everything, so it's going to also inherit some implementations that might be useful. You can actually use it in the mock. What is important is that we pass those mocks into our functions and doing our testing, and then make sure everything is really being called. So this is the main takeaway of this video. So it's really straightforward to create your own mock logger. This was just pretty much exactly logger mock, exactly like the other one. We just mock the methods, explicitly tell what are the inputs or the outputs, and then we can just call it like this. And yeah, this was lacking it should work. So here I am fully sure that the info method is being called with this specific argument. So this is also something we can check. I can check if this exact same string is being passed as an argument to my function, to my mocked method. So I can check everything. I can check if the return is well, if the import arguments are well, the relationship between the returning value and the method of the system that I'm calling. So it's a lot of freedom and a lot of thinking that we do for creating proper and nice tests. Now let's talk about a bonus feature of today's video, which is pipeline and GitHub Actions. So usually it's very important that our testing stage of our software happens somewhere else, not only our local machines, but rather in different machines, in different OSs. And what helps us do this is with pipelines definition. So what I did was I made a repository over GitHub of the same tests, let's say of the same projects. And you're gonna learn how to create your own pipeline in GitHub, at least on the free tier part, so that you may already be kind of getting started with porting all this testing thing. So let's say you're an expert of testing. Okay, how do I move this testing, the actual execution of my tests, the feedback loop to the development cycle of my product? There are many implementations of this, but I think it's good that we do it over GitHub. So what we do is we simply create a folder called .github. Then we create a folder called workflows. And then we can create a pipeline. So testing YAML. And I took this from the example of GitHub. So what matters is that this pipeline, we can configure how it's going to be running, which branches. We can specify which kind of environment variables are passed to our build system. And then we just pick up make this machine in GitHub already has a Cmake. So this is really nice. So I didn't do anything. So this is just a template project. And I believe this is enough because it does the building. So it creates the build folder. It does the build type. So it passes the release thing. It builds and also execute the tests. So let's see how this works. So all I did was just create this file. So I'm going to commit this testing pipeline. I'm the only owner of this. This is directly pushing to master, and let's see what happens. So if I go to GitHub again, we see something happening. We see a pipeline was queued, and we can see our pipeline working. It looks like it didn't find the tests. I wonder why. Actually, I know it. We didn't pass this option to our build system. So we will do it. So recall that if we want to make sure this works, we have to pass this option with on. So let's do it. So let's push it again. Let's see what happens. Yeah, it's running a second time. It should now pull, yeah, the actual testing part from Cmake. It didn't find the Google test. Of course, I didn't install it. Thankfully, this is an easy thing to configure in the pipeline. So I can make a new step here. Let's just call it pull dependencies. And I'm gonna run, looks like it's called libgtestdev. So this should be lib GMock dev. For the last time, hopefully. Okay, looks like the Cmake build worked. Perfect. All the build files were written, and look at that. We successfully ran our tests over the pipeline, GitHub actions, and now you know how to do it. If some failure happened, we would see a red thing here, an ugly thing. And now everyone knows that our repository is somewhat trustworthy. Okay, I hope you enjoyed it. This was fun to do, this one. It's very important. So whenever we, go for industry jobs, we apply for specific roles, software engineering, testing is so much important. So it's very important that we care about this. It's very important that we express our authentic interest in testing. Take that as you will. It is important that we really care for this because at some point we will take care of a software product, and the software product has a quality, and the quality matters. It has a deep impact overall for the entire life cycle. It has a deep impact for the end user. What I'm trying to say is that you should care about testing. That is all I'm saying. So if you're starting a new project, if you are already working some kind of projects, just keep in mind, testing is very useful and very important. That's it for this video. Thank you so much for watching, and we talk soon.